Okay, before we get started, I want to take a look at this picture. It has a picture of a sign that you find in an amusement park. It says, riders must be at least 42 inches tall. Well, what does that mean? How tall do I have to be if I want to go? That means I have to be 42 inches or taller. We can represent this with math symbols. It would look like this. Pick a variable for your height. Let's use h. You could use x. We know my height has to be greater than 42, but it could also be equal to 42, because we said 42 or taller. So that's what the symbol is here. This is a greater than or equal to symbol. Your height has to be greater than or equal to 42. A lot of times, because these inequalities have lots of solutions, we like to graph them. So I'm going to find 42 on my number line, which would be between 40 and 50, a little bit closer to 40. I'm going to put a dot there. And then I would shade to the side that would make it true. So I need numbers that are greater than or equal to 42. So numbers to the right. Next one, we got a speed limit sign. The speed limit is 80, but the minimum is 40. How slow is too slow? Well, too slow would be anything smaller than 40. So I want all of these numbers over here until I get to 40. But I can't go 40. My speed has to be less than 40. Not less than or equal to, but strictly less than 40. If you're less than 40, you're going too slow. So what we're going to do is, because since 40 is not too slow, we're going to leave an empty circle here and drew all the numbers that are too slow. So the difference between this problem and the last problem is that we had the number included and we had the number not included. So over here, I was less than 40, so I don't want to include 40, so I use an open circle. Over here, I was 42 or taller, so I had a solid circle. That's the difference. Solid circles are when you can equal the number. Empty circles are when you can't equal the number. Let's look how that translates to solving. You've solved this for a couple of years now. You would subtract 10 from both sides, and you would get x equals 5. That's your solution. It has one number that makes it true. 5 plus 10 equals 15. But over here, I got x plus 10 is greater than 15. Very similar. I subtract 10 on both sides, only now I get x is greater than 5. The difference is pretty stark. X equals 5 has one solution, just 5. X is greater than 5 has what we call infinite solutions. Not every number is a solution, but every number that's bigger than 5. 5.1, 5.2, 10, 55, 36, all kinds of numbers are bigger than 5. So inequalities have a lot more than just one solution. You get a bunch of solutions. So a couple things that you want to remember when it comes to solving inequalities. First thing, and these are ideas that you probably might recall from last year. They are solved just like equations in this sense. Whatever you do to one side, you do to the other. Whatever you do to one side, you do to the other. Okay, that's a big key, just like in equations. Okay, whatever you do to one side, you do to the other. But the trick to inequalities, and you might remember this, is if you multiply or divide by a negative number, you know where I'm going with this? Hopefully remember. If you multiply or divide by a negative number on both sides, you have to switch the inequality. If you don't remember exactly what I'm talking about, we're going to look at several examples to kind of reboot your memory. But the key here is that when you multiply or divide by a negative, you have to switch the inequality. So your less than goes to greater than, your greater than goes to less than. Let's look at some examples. Just keep these things in mind. We're going to solve it, then we're going to graph it, then we're going to check it. If it helps you, you can always put your line down the middle of it like you're used to doing with equations. And we're going to get rid of that 6 by subtracting 6 on both sides. And then I get the 4x. I bring down the less than, because I didn't add, multiply, or divide. 48. And then we're going to divide by 4. Now I am dividing, but am I dividing by a negative number? No, so it just stays x is less than 12. So I've solved it. But because this guy has an infinite number of solutions, not x equals 12, he has all numbers less than 12, I'm going to graph it. So the easiest way to graph it is I take my number 12, I put it in the middle of the number line. What's to the right? 13, 14, 15, and then 11, 10, 9. And because 12 is kind of my boundary, I'm going to use an open circle. It's not equal to 12, it's only less than. So I do an open circle for less than, and I want all numbers that are to the left or less than 12. So again, x is less than all numbers less than 12. So I want numbers up to 12, but don't include it, so we leave it empty. And I want all numbers that are smaller than 12. So these represent all of the solutions right here. Let's come over here to this one. Draw a line down if you want. First thing I'm going to do is get rid of that 21 by subtracting it on both sides. Nothing weird with subtracting, I don't have to worry about anything. Bring down the negative 3x. Bring down the less than or equal to. It's negative 15. Then I have to divide by a negative 3. None of this is new, this should be all review. But here I divided both sides by a negative 13 or negative 3. When you divide both sides by a negative number, that's the key that we have to switch the sign. So I get x, switch it from a less than to a greater than or equal to 5. That means all my solutions are bigger than or equal to 5. So I'm going to put 5 down the middle of my number line, fill in the rest. Because I'm greater than or equal to 5, that means I want a big solid circle. Because 5 is one of my solutions. Over here 12 isn't. But here 5 is. And I want all numbers greater than 5. So numbers greater than 5 are 6, 7, 8, so forth. Now to check your answer, one of the things you do is just pick a solution where you shade it. So if I shaded 9, I can come over here, plug in 9. 9 times, this is 4 times 9. 4 times 9 plus 6. Well, 4 times 9 is 36, plus 6 is 42, and 42 is indeed less than 54, so that's my checking. Over here, I want numbers that are bigger than 5, like 8. So I got negative 3 times 8 plus 21. Negative 24 plus 21 is negative 3. Is negative 3 smaller than or equal to 6? Yes, it is. So that's how you check it. You're drawing your solutions here, so just pick one of your solutions and plug it in. Alright, last two examples, but none of the rules are different, it's just solving. Okay, we're just trying to get a variable together, or by itself. So first thing I'm going to do is get rid of that 2 by adding 2 to both sides. Then I got negative 2/5 w is less than 25. Now how do I get rid of a fraction? There's lots of ways to do it. I don't care how you do it, you just kind of need to remember it. One way to do it, what I often do is say, okay, I'm dividing by 5, so how do I get rid of dividing by 5? I multiply by 5. But if I do it on the left, I got to do it on the right. So this is negative 2w is less than 25 times 5, which is 125. Then I have to divide by a negative 2. Uh-oh, there's that dividing by a negative number again. When we divide by negative on both sides, we have to flip the sign. Greater than, so we go from less than to greater than negative 62.5. Now how do I graph that? Well, you can count by 0.5s and do negative 62, negative 62.5, go that route. I'm just going to put negative 62 here, negative 61 here. I'm just going to do whole numbers, which is okay. And then just say, where is negative 62.5? Well, it's in between negative 62 and 63. It's not equal to, so I want to do an empty circle in the middle. And I want all numbers that are bigger. Well, the bigger numbers are over here. And then you can take any number you want and plug it in and check to see if this side is less than 23. Now I'm going to go to this guy. It's the first thing I would probably do in a problem like this when you have parentheses. Well, hopefully remember you distribute. 3 times 8x is 24x minus 3. Keep the same inequality. What's different about this problem is we have variables on both sides. I don't like the variable on the right, so I'm going to get rid of a 2x by subtracting 2x on both sides. Not just a 2, but a whole 2x. So that's 22x minus 3 less than or equal to negative 4. And then we're going to get rid of this positive, or this negative 3 by adding 3 to both sides. 22x is less than or equal to negative 1. I'm going to divide by 22. I'm going to get a decimal, or a fraction. Negative 1 divided by 22, it's a really ugly decimal. As a fraction, it's just pretty simple, 1 over 22. Now where would that be? That's really close to 0. It's in between 0 and 1. Where would it be? It'd be right around here. Now I lost my greater than sign, right? All these were less than or equal to. So that because it is an equal to, I want a solid circle close to 0. And I want all numbers that are smaller than it, so they're over there. Alright, so keys for you to remember. Solve just like you would an equation. All the things that you learned back in math modeling and then first semester here, you solve normally. But if you ever have to divide by a negative number on both sides, you have to flip the sign. Over here I divided by a positive, so I kept the sign the same. Okay? Most of your answers will be nice, a little bit prettier than these, but either way, you make a number line filled in circles if it's an equal, less than or equal to, greater than or equal to, empty circles if it's strictly greater than or strictly less than, because we're not including that number. I have 2 examples for you to try. Pause the video, do the first one, check to see how you did it, maybe go back and look at one of the examples if you got it wrong, then unpause it, or pause it again and do the second problem. And then you're not done here. There's still another slide, so just go ahead and pause it and work these 2 problems. And here's the solution to number 1. Take a look at it, see if you might have done it differently, and that's okay as long as we got the same answer. Just a reminder, this is the answer right here. This is the graph. So there's my solutions. This is the graph of the solutions. Go ahead and pause it again and do number 2. Okay, On this problem, again, you might have solved it a little bit differently. I can already tell you I made a mistake just by looking at it, and that's right here. I divided by negative numbers, so that means I need to switch my sign. So mine needs to look like this, which means I need to change the order, because I want no numbers that are less than 3. So make sure that if you divided by a negative, you flip your sign. You may not have, depending on what you did earlier on, and you used a filled-in circle. And then your numbers that you are shading are numbers that are smaller than 3. Okay, that's the last problem we had to do. But I always want you to spend some time reflecting on the concepts that we learned. All these questions can be kind of figured out by going back, looking through your notes, or watching the video again. But we will go over these in class, so be prepared to discuss these. And hopefully someone will shed some light on any of them that you do not understand.